Hello, everyone. So this is another MathCON problems. This is actually a practice question on the finals ebook. So let's look at the question. So number 19. So we have a shop offers different like flavors of like those uh, donuts, right? And we have glazed chocolate, strawberry, and the cinnamon. So the guy wishes to buy 12 of those, including at least one of each. Okay, how many possible ways that person can actually buy those? Okay, so this is actually a really special like type of question. So if you kind of know the star and bars, this is really easy question. But if you have no idea about it, so maybe it's a bit challenging. Maybe we'll do casework a bit. So let's actually do this both ways. So I'm gonna call the number of glaze. Let's say that person will get A, and this is B, this is C, and let's say this is D. Okay. At the end of the day, so the guy will have A plus B plus C plus D. This guy should be 12, which means the total number of like donuts will be 12, right? And these A, B, C, Ds should be at least one, so we can go with some casework. So if I just go with, let's say this is one, this is one, this is one, that's three already. So that means this has to be nine. And if I change like only one at a time, so I can go with this is two, that should be eight. So these two still one. Maybe I can write it, but this is three and this is gonna be seven. So I can continue doing this all the way to the like maybe this is gonna be nine and this is gonna be one. So when the first two is just one, the last two can be arranged like one through nine different ways. So we have 9 ways to do this. Okay, so that's the first thing, but that is not the only one. So I'm gonna change now like this guy to the two. Okay, so let's do that. So let's still say this is one and this is two, and that could be one, right? So that would be three, four, so we should have eight, and that will be two, seven. If you continue in this all, so that should be eight and one. As you see, if the first is one and two, like the number of glaze is one, number of like chocolate is two, then other two types, we could just choose 8 different ways, which is gonna be plus eight. And if you do this with the next one, so I hope you'll see what's going on. So if you make this three now instead of two, okay, so let's say this is three and that will be four. So this is five to get 12, so it should be seven. So two, six, and all the way to the seven, one. So there will be 7 ways to arrange the last two if the first two is one and three. So as you see, it just start with nine and then eight and then seven. So you will continue all the way to the one. Okay. So you can confirm that if you like to. Okay, then I just need to add these guys. If you do remember the Gauss approach, Gauss formula, so sum of the first 9 integers is just 9 times 10 over 2, which is 45. Okay, so this is the number of ways to arrange if we have only one of these glazed ones. Okay, but now we are done with that, so we can just go with now the number of glaze will be two. Okay, so if this is two, let's say this is one, that's already four. So that should be eight. So that's two, that's seven, all the way to the eight one. So that will be 8 ways to do this. And then I have eight. And if I do this two, two, one, seven, all the way to whatever, I will get seven and all the way to the one. So the same like case that we did just right here. So it will be happening there. So 1 through 8 will be 8 times 9 over 2, which is gonna be 49 is 36. Okay, and if you do this now with the next one, so which is not gonna be too challenging at this point, I guess. So I can go with now 2 2s, right? So let's go with that, 2 2 and 1, and then that's already 5, so that should be 7 2 6 all the way to the 7 1. So you will see that will be 7. So that means, the first number is just decreasing by 1 every time when you increase the one of these numbers by 1, because that will decrease the number of ways to do the last two, which is kind of expected. So that will be 6, 5 all the way to the 1. Okay, and that's going to be 7 times 8 over 2, which is 28. And I hope you see what's going on. So you don't really need to list everything at this point. So you can just say, okay, 6, 5 all the way to the 1, which will be 6 times 7 over 2, which is 21. And if you do the next one, so that will be 5, 4 all the way to the 1, which will be 5 times 6 over 2, which is 15. And you can see them. And I think we don't really need to do the remaining ones. So 1 through 4, maybe let's actually write it. 1 through 4. 4 times 5 over 2, which is 10. And 1, 2, 3 will be 6. 1, 2 will be like 3. And then the last one will be just 1. So if you add these guys, okay, that will be just number of different ways to get those 12 donuts, right? So you can just find the assignment maybe a different way. So if you add these guys, that's 60, and that's 96, right? If you add these, so that's 100, and then 128, 49, and 55, and 65. So that is the answer. Okay, this is the longer way. If you kind of didn't like it, that's okay, but it's really nice to try this approach as well, especially if you have no idea. And then sometimes this is actually better than maybe other ways, even though it's a bit complicated, especially if you miss one of those steps or add them a bit wrong, whatever. So your final answer will be different. So that's why you want to be careful. But that's the first approach. The second approach is just actually a bit better. So we are going to start with the same approach. So A plus B plus C plus D is 12. And we like to have A, B, C, D at least one. So we call the second approach star and bars because we are going to use some sort of like stars. Okay, let's have 12 and stars. Okay, so we have 3, 6, 9. So if you have like 12 stars and then you just need to split 12 stars or 12 donuts, whatever, into 4 groups. So, you can make 4 groups if you like divide them with 3 divider. And then you can just divide this way. If you do this, the first number will be 4, second will be 3, the third will be 2, the last one will be 3. And you don't have to do this. You can just do like this way or that way and this way. The glaze will be 1 and chocolate will be 6 and strawberry 1 and the last one is going to be 4. So the question just became how many ways actually we can place those 3 dividers, not 4 dividers, because you want to make 4 groups. So to make 4 groups, I need 3 dividers. But at the same time, I cannot place the divider right here because if I do divider right here, so on the left side of that divider, there is no stars, which means there is no donuts, like donuts. So we cannot really have a number, which is we are asked to have at least 1. So which is why we just need to have those divided among those, like placing between those stars. Since we have 12 stars, if you count those like spot, we do have one lesser number spots than the number of stars. So since we have 12 of those, so that will be 12 minus 1, I guess, stars. Okay. And we just need to place 3 divider to make 4 groups. So which means 4 minus 1 dividers, right? Dividers. So that is why we just need to choose 3 dividers out of 11 stars, basically. So 12 minus 1, choose 4 minus 1. And that is 11, choose 3. And if you do 11, choose 3, so 11, 10, 9, right? And divide by 3 times 2. And I can cancel this. This will cancel that. So 15, 11 is just 165. And this is much better in this case, but it's still the first approach is okay. So I will probably do both ways whenever I need to, especially if I have enough time, okay? So I hope that was clear, and this is just another example of star and bars, and I'll see you in the next video.